Hi, I'm Fernand Brunchwig. Quickly, welcome. This is a STEM Teachers NYC coordinated session, but we have Peter Bohacek on the line as the host of the founder of Pivot Interactives, and we have Matt Vonk on the line, who's his colleague, and we have Craig Buszka, who's charter and board member, board chair of STEM Teachers, who's expert user. Go ahead, Peter.
Yeah, hi. The purpose of this is that all of us teachers have found ourselves suddenly in a place we probably never expected. Let's see, I'm going to admit people as they arrive, with suddenly being asked to teach everything online. And as teachers ourselves, Matt and I are in the same position as all of you. We're trying to figure out how to manage this as well. But at the same time, we are in a somewhat different position because we've been working on Pivot Interactives for coming up on a decade here. And we're really pleased that Pivot Interactives can be helpful to all of us. We're pleased that it can help our own students, and we're even more pleased that it can help yours. And so the purpose of this is to try to help you figure out how to get maximum value out of what we've already done. We're in a tough position because we know that what we have is something that costs money. And so what we want to do is find a balance. We think we have lots of really good free things that we're hoping people take maximum advantage of. And then also we can talk about, if you decide you want to continue to use it past our free trial, we can talk about that as well. Matt, do you have anything to add?
Yeah, just that Peter is a high school teacher in Minnesota, and I teach at the University of Wisconsin, River Falls in Wisconsin.
Right. Thanks for putting that in. So Fernando, we had a couple questions we wanted to ask of the people here so we could get a sense of what people's needs are.
You're muted, Fernand.
Okay, the first question is just, we'd like to gauge how familiar you are with Pivot. So like if you used Pivot before, please go to the chat window and enter, yes, I've used it, or no, I haven't. To get to the chat window, just hover your cursor on the bottom toolbar and there should be chat. Okay, so a lot of no, yes, mostly no, okay. And then the second question that we'd like to ask, and feel free to keep on answering that first one, is what is your discipline?
Right.
Okay, physics,
that fast.
Physics, chemistry, biology, astronomy, physics and chemistry. Okay, so it looks like in general, most people are not familiar with it, and most people come from physics and chem. So Peter, can you give us kind of take us through that?
Sure.
I'll be reading the chat window, so if you have specific questions, go ahead and type them in the chat, and then we can get those answered as well.
Matt, one specific question that's been asked is this meeting being recorded?
Yes, it is, and I think Fernand will post it after it's done. So, yeah, if you want to go back and take a look at it or refer colleagues to it, it'll be posted.
Okay, so I'm going to share my screen and see if I can figure out how to do that.
Fernand,
here we go. I got it.
Where they can find the recording? Can you answer that in the chat?
I don't have that now. We will do that, but I don't have the answer right now.
So I'll volunteer just a bit of information. Yelena Desmond, Program Director, STEM Teachers NYC. We have a page of virtual teaching resources. So we're going to be housing or hosting the videos that we record across several sessions there. And we're going to turn that into something a little bit more dynamic in Google Sites in the next week or so. So go to our website.
Great, and can you all see my screen now? That's the window, scrolling window that says Pivot Interactives on top.
Yeah, looks great.
Okay, great. Okay, thanks. So So what Pivot Interactives is, it's a tool that you can use with your students to use interactive video so that students can use events themselves, scenario and phenomena, events themselves to make measurements and observations. So the main difference between Pivot and other kinds of video instruction is that Pivot isn't video instruction. The student, there's no narration, there's no descriptions of things. It's an event that the students are using to learn about science phenomena. Another difference that it often gets compared with simulation. So we've heard people say things like it's like PhET, and it is. It's a lot like PhET, as you'll see. But one main difference is that all of these are real phenomena, and so they vary from ideal situations in really interesting ways. And that's part of the beauty of it, is that the students get to see both these ideas that you know, these sort of simplified models that we all like so much, but then also how things don't match exactly what we would see in a computer simulation. So I'll just show you a quick example, or for physics. Telling me that my internet connection is slow, and I can see that it is. So Matt, we may have to have you jump in and get ready to share if this doesn't load quickly.
Okay. Yeah, and even you were kind of frozen occasionally and the sound broke up a little bit. So I might just try sharing my screen.
Oh, looks like I got it now.
Okay.
Yeah, let's just see if this goes okay. Normally I have not had problems with my internet, but this would be a perfect time to do it with 50 people here. Okay, so this is an example of a Pivot Interactives activity. So the idea is that this is what your students would see. And so it's got written instructions about what it is that we're trying to do with this activity. In this case, they're going to be applying the conservation of momentum concepts to a situation. So this would be something where they would already know about conservation of momentum, and you'd want to give them a chance to try it, sort of an alternative to a word problem or an alternative to a very simple lab. All of the instructions that you see here are modifiable by the teacher. So we can show you that later, but if you like different wording, or if you have a different purpose for this video, you can change the text that you see here. So this right here is an example of now an interactive video. So if I play this, and I will see whether you're able to see it. So I don't know what that looks like on your screen with my slow internet, but
it looked great. Yeah, it looked good.
Okay. This blow dart coming out of here, and you can see that there's actually two marbles inside this blow dart and a blob of clay. And then the blow dart hits this cart, the cart kind of leaps in the air for a minute and then moves. The kinds of interactive tools that the students have for this are very simple, just a drag and drop ruler that's already calibrated for them in centimeters, and then a stopwatch. Since this video is recorded at 240 frames per second, the stopwatch is calibrated for making timings for this slow motion video. So the idea for this activity is the students can look at what we call trial one here, and trial one shows them an entire collision. But then their instructions are that they should select one of the subsequent trials. So I'll just select trial 4 here and press go. And it loads a different version of the same collision. So it tells them the mass of the dart in this particular case and the mass of the cart in this particular case. So now you can see that this cart has got an extra metal bar sitting on top. And so now when they watch the video, all they can see, sorry, that was very short, I'm going to slow it down. All they can see is this blow dart emerge from the blow dart gun and then hit the cart, and then the video abruptly ends. And so what the student's task in this case is to predict how fast is that cart going to go after the collision. And so we asked them some questions about how are you going to do that? What measurements do you have to make? What system did you decide to analyze? What assumptions have you made? And when they're finished with that prediction, then they hit this block, answer, and continue. So because you're mostly physics teachers, you know that we're going to just measure. We can reset this stopwatch. We should probably wait until the dart completely emerges from the. And so what an example of a of an assumption that the students are making is that this dart is going to move at constant velocity as it makes its way across that little intervening air. So there I've reset the stopwatch. And so now the students can use frame by frame advance on their keyboard so they can really get a nice precise measurement of the distance and time for that flow dart. And then calculate its momentum because they know the mass, watch it completely embed itself. And now they know that this new moving object is a combined mass of those two, right? And they make their prediction. So here we have this lock, answer, and continue. So the students, since they're going to make a prediction, we want them to actually say, this is really what I think is going to happen. And
Peter, can I interrupt for a second?
Absolutely, Craig.
Could you scroll back up?
Yeah.
To the video. My name is Craig Buszka. I teach physics in Central New Jersey, and I've used this video a lot with the kids, and I think there's opportunities for great discussion with students about why they're measuring things, what's the best method to determine the velocity of the dart, and these are things that may seem obvious to a teacher, but to a kid considering something for the first time, it's a rich opportunity to be very intentional with the students about how to make measurements. So one question the kids ask is, as Peter mentioned, should we wait until the dart is emerged from the gun before we start to measure its position? And so you could ask them to take data for that and to determine when is it going to move at a constant speed, and justify their decision to do that. So it's these little things, these little decisions that we have to make, which I think are part of the richest part of Pivot for me.
Thanks, that's great. And the challenge for the teacher is to decide, how to balance that, because students will naturally have lots of questions about making good measurements and precision, and even there's some tension because they'll say things like, well, when I'm trying to make this measurement, I can't see exactly, so maybe they're going right here, and they're like, what should I call the position of the tip of that dart? And that's exactly the kinds of things that are normally difficult to address with students, and it really comes to the forefront here. Matt, do you have comments about that?
Just that I love in this video that they can actually make a prediction and then go into the second part and see whether it came true or not. See how close they got.
Yeah, I like that too. So then, right. So then this is where they would go and then select the same trial that they had the first time. And I agree. I think this is almost where the fun part of it comes, because now the first thing they want to know is, did I get it right? And so they can measure the velocity using the same ruler and same stopwatch as before, and they find out if they're right. But I think for a lot of us, this is the place where often our lab activities stop, and that's unfortunate, because it's really okay, they're not going to be exactly right. They're for sure they're going to have a difference between their prediction and the result. And so the question is why? So we step them through that, because we know that that's not easy for students to answer that question. They're so used to answering, am I right or wrong? And maybe by what % am I wrong? But why? What does it mean? Like, what else can I figure out about this? So what we do in our class is that since every student does a different trial, we can look at things like, well, was everybody off the same way? And if they were, what would that mean? So if everybody found that the velocity of the cart was lower than what they predicted, what does that mean? What can we conclude as a class if that happened? Or what if it was higher for everybody? And what if it's mixed? And so you can very quickly get this very rich data. It probably only takes 10 or 15 minutes for the students to make the prediction. And then you can have this really rich conversation about what else can we learn about conservation of momentum and the effectiveness of using it from a group of results that we have from these 15 collisions, 15 sets of results. Okay. A lot of cases
so some teachers, like maybe they've already done momentum or they teach in chemistry. Can you give us a tour of the library and show what kind of variety and topics there are?
Thanks, Matt. That's a great idea. Yeah. So you have a variety of different ways that you can search. If your state uses NGSS or something like it, or if you teach an AP course, then these are probably the best search tools. Uh-oh, hang on a second. Just a moment. Okay. So, right, thank you, sorry about that. So there's over here, so for example, if you teach AP Physics, you can bring this down and look at, so there's momentum where we just were, but you can, and this is probably the best way. You can use the text search up above, but I think it works better to just go through these category searches. So if you're, then also you can do things like search by NGSS science practice. So if you say, I'd like a question that will involve graphing, you can narrow your search by NGSS science practice. And we also have more traditional tools down here, just organizing it by subject area. And then also by what type of activity it is. Is it something that we use as a flipped lab or an assessment or a goalless problem, or using the aisle teaching technique?
Peter,
can you select chemistry and just show what some of the chemistry videos look like?
Sure. Yeah, chemistry is interesting because when we first started doing this, I think we, like most people, thought, well, video analysis is about like projectile motion and free fall, and we're gonna do position versus time graphs, and of course we have lots of that. But we found that chemistry and biology, really, there are great opportunities to do interactive video for that as well. So I'll just show you a couple of examples. So energy in chemical reactions is a big theme in AP chemistry and also in next generation science standards. And so here's an example of that. So we have the students can choose what substance is going to be dissolved in water, and they can choose the amount of the substance. And so I can choose calcium chloride and 50 grams of it. And so what you really see here is this is a matrix of videos. And this is one of the things that we really like about Pivot, is that students have freedom. You can say, why don't you there are all kinds of questions you could ask them that they can answer by choosing different parameters here. So I just chose calcium chloride 50 grams. And so it'll load that video. And again, just worth pointing out, this isn't a simulation. We recorded every single one of those combinations. So now the students can watch, they can see that that's 50 grams, that the water that's in the container is 20 degrees C. And we've recorded it simultaneously with an infrared camera, so students can see that as soon as that was added, that this container of water begins to heat, and then we're stirring it with the thermometer so they can see really what is the temperature of that. So it's even better if students can, put their hand on the side of that beaker and feel how hot it is. But on the other hand, we use a lot of chemicals here, which you really wouldn't want to do that. Plus, obviously, in our current circumstance, we just can't. So
Peter, there's a question about where the data goes that the students record, and how can you access that?
So with the data that's so first of all, so the idea in this activity is we're going to make a graph, and we've kind of given the students this is a little bit more structured than most, where we've said you're going to put the amount of substance on the horizontal axis and the final temperature on the vertical axis, and make a graph, and then use that graph to find the molar energy of solution. And so first I will show you, as a teacher, you can look at answers and notes. And so here's sample data. And we've actually put sample data for all of the different substances in here. And so you can see for sodium hydroxide, and actually this is calibrated now in kilojoules on our vertical axis and grams. So we can do kilojoules per gram. And we've got our linear regression tool so we can see a slope. So that's where you can see that as a teacher. Now, as a student, as they're typing this in, it's all auto-saved. So you, as an instructor, you select an assignment like this, you assign it to your students, they open it up, they do put their responses in here, and it's all saved as you go, and then you would go to your classes where you can look at the responses that students have typed. Can you check, Craig? Does that answer the question? Is that what they were interested in finding?
Yeah, could you did you show the list of students in your classes?
Sure, I can do that. What account am I logged on to here?
Okay,
well, this.
I think people would want to know that they can see every student's answers, or they can select questions that they want to look at.
Sure, yeah. So we can. This is sort of a test account, so I don't have real student data in here. It would be nice if I did. Let me look at this one. Yeah. So I can still give you the right idea. So these are the classes that I've got set up. And oh, here's a bunch of data. Oh, and these are teachers that were at a workshop. So this is fine. So sorry, let me back up. So I have this class set up that was during a workshop. I assigned 2 activities during the workshop, and then as they type their responses, they're all recorded. And so this is a list of the people that were in the class. And so you can see, in this case, you can see that a lot of them didn't open the activity. So they're just, it says last change by instructor. So really the only ones that did put any responses in are these ones that you see in yellow here that say student. And so, right, what Craig said is really important. There's 2 ways to grade. You can grade every student individually. So I can click here on Barb's response, and I can look at what Barb typed. And she put an answer here. Sorry, that's a multiple choice one. So that one is auto graded. Let's go down to, so here's an example of one where she wrote an answer in here. And so then I can put a score in here, say, great job, Barb. Right, so you can do that, but you can see that that's gonna take a while. And then you can work your way down and save and grade the next one and work your way through your class. And sometimes you wanna do that. But in a lot of cases, what's faster is to go over here and say, I wanna grade by question. So I'm gonna go back up to this one, grade by question. And now what I can do is select up to 5 questions on this and say, so for example, let's look at one of these written ones. Here's an open-ended question. What do you notice that all of these have in common? So I'm gonna click that, give it a default score of 5, and maybe that's the only one I wanna grade on this one. So I can scroll down, say grade questions. And now I can see, here's Julia's response to that, Barb's response to that. And so I can kind of quickly go through and change the grades, add a comment. I can either save as I'm working, or I can grade all the way through every response in the class and save at the bottom. So I found that this is really useful for me to get a quick snapshot. Like maybe their homework was to create a graph, and I want to see real quickly, like, did they get good data? And so you can just scroll through in just a couple of minutes and get a snapshot, an overview of how the students did on that particular question.
Peter, there's been some questions about whether students can revise their work after it's been graded.
Yeah, they can. Right now, this is a platform that we're constantly using teacher feedback and student feedback to revise. So right now you have, as a teacher, you have an option of being able to accept or not accept responses at a class level. So you can say, for this assignment, I'm going to make it so that nobody can change their responses, and then you can grade it, and then you can open it back up and allow them to revise theirs. And actually, I really like doing that because I often will go through and not grade it, but comment and say, your data looks good. This is going well, or here's some suggestions for how you can improve your data, but not score it. I've noticed that the students tend to pay less attention to the comments if they'll just look at the grade. So this way I can say, okay, here's advice for how you can improve this. Now you can open it up and revise it. So we do have that ability.
Yeah.
There's a question about Google Classroom. Does it sync to Google Classroom, or do the students have to create accounts?
we don't have single sign-on, so there isn't a way that they can sync their user accounts with Google Classroom. That's something we are definitely looking at doing in the future. We have the ability to do that with Canvas and some other learning management systems, and we're building that as fast as we can. What you can do in Google Classroom or in any learning management system very easily is you can, when you've created an assignment, I'll go back to, it's asking me if I want to save, and I don't. After you've created an assignment, there's a button here that says copy link. And so I can make a URL now that I can embed in my class calendar, and it will only work for students in Barb's class, and it'll only link them to that activity. They still have to log in, but it's a quick way to direct them to the activity that you want to work on that particular day.
And does it work on phones? Does it work on a cell phone?
That's a great question. One of the ways I like to think about that is, would you want to type a term paper on your phone? And for me, the answer is no. And yet students do it all the time. And I think it's similar for Pivot Interactives. I would not want to use Pivot Interactives on a phone because the screen is too small, but all of the functionality works.
Thank you.
Yeah.
Peter, there was a question a few minutes ago about how to conduct conversations with students about measurement and analysis. I have some ideas about it, but
why don't you? Well, yeah, I'd love to hear your ideas, Craig. Go ahead.
Well, I don't know if it's the best use of the platform to just assign students a lab and say go do it, even when we're not in a pandemic. There's one method I've tried is to take a couple of screenshots of a video and create a document where students ask questions and offer ideas about the best way to take the data and have a little bit of discussion there. We have an online bulletin board that we're using right now, and I posted an essay from a previous year about a student who used one of these videos and had a disagreement with her lab group about the best way to take data for one of the videos. So when my students read that section of the essay, they commented on the essay saying, oh, I didn't think about doing it this way, or they could think of a third method. And so any way to sort of break them out of the confines of their bedrooms while they're doing this is a good way, I think.
Yeah. I noticed on Twitter, I saw a teacher was using I thought a great idea. Her name was Helen Reynolds, and she had a Google form set up that was linked to a Google sheet, and she was having students answer questions in that sheet, and then she and her Zoom class had the sheet set up. So as students were entering their individual responses, they could immediately see how their response compared. So they were looking at trends, and so every student's job was to put their data in, and then the class's job was to look at patterns and trends in that larger data set. I thought that was a great idea.
And that sort of takes the it's aggregated data, so everyone was anonymous with the data they entered.
Yeah, I don't remember if she actually had it anonymous or not, but the idea was, yes, that it was aggregated data, so you can see these bigger patterns that you wouldn't be able. That's a type of collaboration I love, where the collaboration is like you're doing your part of collecting one piece of data so that the class can see, a larger pattern.
Sweet. There's a question about if there's a tutorial video for kids.
Yeah, that's a good question. Matt, what do you think is the best tutorial?
Usually I recommend ping pong ball bazooka, especially if they're in physics, because that has it's more highly scaffolded than a lot of our other ones. And so it asks them to set up the scenario and then place the measurement tools and then ask them to make a measurement. And then there's auto graded multiple choice. And so they can type in their measurement and then get immediate feedback. Because like we said before, even using a ruler, like my students really struggle at it. So Peter, can you just show the video first?
Sure. So so the video is a really high-speed video, I think 2,500 frames per second of this vacuum-powered cannon that shoots this ping pong ball and it goes through a pop can and kind of blasts the pop can into pieces. And it's kind of fun because immediately students are like, that's amazing that a ping pong ball is going that fast. It's kind of dramatic. So then we have the same tools that you saw on there are a lot of variety of tools. So we don't want to make it seem like everything is stopwatch and meter stick, but these couple are. And this really lets students explore some of those things that Craig was talking about, like when do we start taking measurements? Where do we put the ruler? When do we start timing? Do I leave this stopwatch running, or do I reset it? Do I use the middle of the ball as my reference point for measurements, which is, I think, a lot of times what students want to do. And so here, like Matt said, we take them through, like, how do you control the video? And we have them start off by making a measurement that has nothing to do with the motion, to measure the distance from the right edge of the ball to the left edge of the pop can. I think that's a mistake. Is that right, Matt?
Left end of the ball, the right end of the ball to the left end of the pop can. What is it?
Oh, I see. I'm sorry. It says advance it until the ball is just barely coming out of the. Yeah. Okay. Sorry. That's right. Yeah. So then they can put their answer in and then submit their answer and get some feedback about whether they're right or wrong, and then they can try again. And so this is nice because then they can say, all right, okay,
can I just jump in? So I just asked people what labs they were going to do. And Jane said she is doing the flame test one, and she's already modified it and then posted it on the community library.
Cool.
That's another thing. If you make it your own, take a lab and kind of make it your own, which we all do. Like, we're like, I don't like the way that's written. And so you want to make it kind of fit your particular situation. Then you can share that with the community library and other people can use it. Someone did the hockey puck, the ice going down the ramp, introduction to acid and base properties, another acid-base properties. And Yadana is asking where the community library is.
Right. So up at the top, there are the 3 libraries. There's the library where you have just, so I'll start with this one. The Pivot Interactive library is all of the activities that we've made. That's the searchable one that I was scrolling through at the beginning. Once you find one from there that you like and you want to use it with your students, I'll go back there quickly. You'd say add to my library. Click on that, and then when you do that, you make a copy of it that's now yours. You can make whatever changes you want to that. So there is the one that's copied in there. And so here's what the editing looks like. And if I wanted to share this with the community library, that's what I would do, is click right there, and that'll say that my version, however I've modified it, is now in the community library. And then the community library itself is back up here. My library, that's where I have my things. There's all of Pivot Interactive's things, and that's the community library. And yeah, the community library is getting big. Lots of creative ideas that teachers have for how they are modifying things. And that's also a way that you can share with your colleagues. So if you're at a school where you're like, okay, I teach the physics class, but so do some other people, maybe one teacher modifies the activity, puts it in the community library, and other teachers at your school or other schools can then add it into theirs and use it.
Peter, there's a question about whether we're waiving this for what is our approach to COVID-19? And actually,
why don't you answer it? That'd be great.
We have always offered a 30-day trial because we feel like teachers really need to test it out to see if it's going to work in their class. And so we're continuing that, the 30-day trial, free trial now. And that's a fully functional free trial. And so you can use it with students. You can use it with unlimited students, unlimited classes. Like, we really want you to just put it through its paces and see whether it's going to work for you. We really recognize the severity of the crisis that we're in, and we're teachers and we want to help teachers. So the normal cost for high school teachers is $5 per student per year. And we wanted to take that down to 0, but this is a pretty resource intensive way to approach the problem. We have high resolution videos that require some storage on Amazon and some development. Anyway, what we could do is we're offering the rest of the semester for $1 per student at the high school level and $5 per student at the university level. So we hope that is works for many teachers. We've seen a ton of interest. So that's our COVID response. If you think that this is something you want to use long-term, then you can also purchase now for the regular $5 per student per year rate, and you'll get the rest of this semester and next year.
If I could just tack one thing onto there, our first reaction when we saw the magnitude of this was we have to just make this free because teachers need it so badly. And we very quickly got with the suppliers who we have to pay to keep our platform running and did some models of what we thought that would look like. And it just became immediately clear that it would strip us of, we would have nothing left. And so we thought this would be a very bad decision for teachers if in the process of trying to do this for free, we ran out of money. And we were absolutely confident that that would happen. And so that's why we came up with this compromise where we can afford to keep it going at this price, at this reduced price. And I guess I'll just go ahead and say that it's something that we thought a lot about, and we understand that there are people that look at this and say, if you're charging anything for it, then they're not really trying to help teachers. And we just want to say this is the best decision that we think that we could make that would allow us to not go out of business and help teachers.
Peter, there's a question about whether if a teacher can transfer from one student to another within a year. So let's say you have a kid who transfers out of your class, but another kid shows up.
Yep, you absolutely can. The seats are for whatever duration they are. Let's just talk about a one year seat because that's our normal thing that we do. If you buy a 1-year seat, that gives you the opportunity to have a student in your class, not a particular student. So you can, at semester time, or if you buy seats now and then use them next year, well, probably all of the students aren't the same ones, doesn't matter. You can add and drop students during that year, so long as the number of students enrolled is less than the number, equal to or less than the number of seats that you have in your account.
And does the subscription go from till July? When's the end date? Because there's a question about summer.
Yeah, so the current one, the one that Matt mentioned, the $1 seat goes to June 30th. And normally the seats last a duration of time. So like our normal seat is a year from whenever you get it. And actually not even whenever you get it, when you activate it into your account. So if you bought a 1-year seat right now, normally it would last until 365 days. But as Matt pointed out, we've extended that to say, well, maybe you want to buy seats for the rest of this year. So then they go, if you buy them now, they go to June 2021, right? June 30th, 2021. We don't have, if somebody wants to teach over the summer, we haven't got a specifically discounted deal for that. It would just be the regular one.
Well, this is Ferdinand Brunschwig again. This has been an incredibly intense and illuminating session. There's more questions coming in as we speak. And I think, exactly, I can't answer every single one, but I do want to thank Peter and Matt and Craig. Maybe ask them if they have a final word. And we can keep the chat going, and we will get the recording out as fast as we can, so you can look at it and tell other people to look at it. And we will try to preserve the chat so that maybe we can answer some of those questions afterwards online. But go ahead, Peter, if you have some last things to say.
Sure. Thanks, Fernand. If you go on the Pivot Interactive's website, there's a chat bubble in the lower right-hand corner, and we have our partners. Our distribution partner for this project is Vernier Software and Technology, and if you've worked with them at all, one thing that you know about them is how great their customer service is. And so they have volunteered, because of the crisis and the increased demand that we've had, to have some of their customer support people work on our customer support channel. So if we don't get a chance to answer your question, if you go to Pivot Interactives and go to that chat bubble and type it in, then one of the team will get back to you as quickly as you can. And we're any kind of question, you know, how do you teach electricity with this, or, you know, billing questions, whatever you have.
Okay.
Should we show one
Matt?
more video, Matt?
What's that?
Should we show one more video? Think of a video that you like or that you think people would enjoy.
There was a question about 2D motion videos, so I would plug Follow the Bouncing Ball.
The one with from the drone?
No, well, the one with the kids on the stage with the pole and they're
One
bouncing a ball
series
across the
in the
stage.
field.
Oh, let's do both.
Yeah, just because that one, there's a feature about that one which I don't think's been mentioned yet.
Oh, okay. So let's see, two-dimensional kinematics. Oh my gosh, there's so many of these that yeah, this is tough. I'm gonna start with this one because this is one that we did 2 summers ago. That was one of these ones where, I don't know about you, but I've always said to my students, imagine the following, and I've assumed that they do, and then later I find out they have no idea what I was talking about. But this is the ability to see a 2D projectile motion from 3 perspectives. So we have a drone hovering above, and that's this shot here. So you're just looking at the horizontal motion. The drone is really high above. We used a telephoto lens, so you just see that horizontal motion. And then here is the motion just looking straight at Siri, the girl who is tossing the ball, from a very distant vantage point, again with a long telephoto lens. And then here you see the same event recorded from the side. And so this is kind of the really nice way for students to be able to see all 3 perspectives and then be able to analyze them too. So they can really discover for themselves that the motion in the horizontal direction is constant velocity and so on. And one of the greatest comments I heard from a student when they looked at this was this girl said, how did people learn this before you had this? And obviously there are ways that we've all done, we all learned it without this. But I really like that because it just makes it very, very clear. So this is where they would learn about projectile motion. And then Craig's one, which I'm going to let him talk about, is an application. Like, okay, now that you know projectile motion, here's a great opportunity to practice it. So Craig, what is it that you like about this one?
Well, one of the great things about Pivot, I think, is that there's different videos at different levels of sophistication. So there's videos that you can use to introduce a topic, and videos you can use later on when they're familiar with a model and they're ready to apply something. So here we have 2 kids. There's a stage. There's 2 poles, and you're told in the video the distance between the 2 poles. And the question is about at the first bounce, can you determine the speed and the angle of that first bounce without the use of a protractor? So you're given some distance measurements, you're given a stopwatch, and can you use your model of projectile motion to make an argument about how fast the ball is moving? And one of the features I like about this is that if you scroll down a little bit, the students have to make some measurements and calculations, and they have to commit to an answer before they're allowed to test their prediction. So as an instructor, you can pause the class there and say, here's the consensus opinion, here's some other different opinions. Let's hash it out before we go on and actually measure the angle with the protractor. So it's amenable for a lot of different types of class approaches.
just a quick thing about that. Students' first reaction when they look at this is that there's no way I have enough information. That's the normal reaction. They're like, all I have is a stopwatch, and I know that that's 3 meters. I don't know how high the ball went. Right? It seems impossible. And we actually tested this early on. Remember when MOOCs were a big thing? Like everybody thought like these massive online open courses were going to be like the way we would all teach. And MIT had one, I think probably the most famous physics MOOC, and they tested all these different learning techniques. And one thing that they saw for sure is that the ability for students to, or for people to kind of creatively think about how can I solve this problem that seemingly doesn't have enough information, that we were able to measure a gain in that ability when people use Pivot Interactives compared to when they didn't. So that thing that Craig's talking about, like, how am I going to do this? Your students will get better at that through the process of using that. We've seen evidence of that.
Yeah, I think sometimes the reaction is to make learning experiences so simple that everybody can follow it. And sometimes I think you lose the learning opportunity there. When you have to make a decision, defend your point of view to your neighbor who doesn't think the same way, and make an argument.
And be creative, right? They have to open it up and say, okay, it seems like this is insolvable.
Yeah.
What are you going to do? How will you approach it?
Yeah, so you might say, gosh, that the highest point on the arc seems like a really interesting location that you could use to take some data from there, right up there. Yep. So anyway, that's my two cents.
I thought you were going to say that what you like is how the ball squashes.
Oh, I do like how the ball squashes. In class this year, I used one of the other trials because it's a tennis ball, I think, and I asked the students to make an argument about the average force that the floor exerts on the tennis ball during the bounce. So because I can edit this stuff, I added a section to ask them about that. And the squishiness, I didn't know the mass of that thing, so I just didn't direct them to that part.
Right. Great. Yeah, I agree. I like that. And I did not use this one this year, and I forgot how much I like it.
And the kids wanted to know if those are pool noodles on the stage.
These are, no, they are cardboard tubes from a home improvement store that used to have carpet rolled on carpet. So as all physics teachers know, if you go to those places and ask them for free stuff, they often will give it to you. So I always would go in and collect up things like that, and I use those for sound resonance demonstrations as well. So it's just a cardboard tube standing on end.
Oh, that's disappointing. I told them it was pool noodles, and I told them that the white block on the first video you showed was tofu, about the dart slamming.
Definitely keep telling them that. Yeah, definitely keep telling them that. You can tell them that we confirmed it, that it is a pool noodle.
Okay, thanks.
Well, I see we still have 44 people, so people are not tired, but probably some need to drop off, so you don't have to feel that you have to stay. But,
right. But if you have questions, we're happy to have people stay. We didn't talk about the fact that you can upload video as well. That's a relatively new feature that you can, as a teacher, if you have a video that you want your students to analyze, you can do that. And then so you upload the video when you're creating the activity, and you can calibrate the ruler, and then the students can analyze. Or you can ask the students to record videos. And I think for projectile motion in particular is a great time to do that.
There's some interest about the situation where the class aggregated their data onto a form or a sheet.
Yeah. So I didn't look at Helen Reynolds' example specifically, but an example that I've done is with, and I'm going to show this, but I will show it as a reminder that I really think that Pivot Interactives is about more than projectiles and position versus time graphs. But nonetheless, here's another example. So this is five objects of widely different masses, and they're all tossed upwards and recorded at 1500 frames per second. And you can have this ruler that's there that allows you to have kind of coarse measurements, or you can add this higher resolution ruler, and you can put a stopwatch there. And so this is one where I use a spreadsheet with my students. So we talk about how are they going to figure out what the acceleration of those is, kind of do it as a flipped lab. So we talk about that in class. They design an experiment for figuring out the acceleration. And for homework, they go do it. And then the last step in the homework is that I embed a link to a Google form, and they have to write in there what's the mass that they at and what's the acceleration. And the next day, I put the spreadsheet up and they can see the masses that each one of their classmates use and acceleration. And it's so crazy how they are, even though you feel like we've talked enough about Newton's laws and they understand how forces and acceleration are related, and they've even been through the derivation, that when they still see that everybody is like that everybody got the same acceleration, regardless of the fact that the littlest one has a mass of 8 grams and the biggest one has a mass of 500 grams. And it's just a great example where their combined effort, their combined data tells them something that, for whatever reason, me telling them did not have that impact.
Yeah.
Yeah, we have an unusual way of making a velocity versus time graph that people will have to explore. At first, it seems different. It's not just a push of a button and it converts your position versus time graph into a velocity versus time graph. Students make little slopes of little increments and measure the velocity using the linear regression tool for each one of those, and then build a data table and add those individual velocities in there. It only takes them about 5 or 10 minutes, and we feel like it really helps them understand that what they're doing is actually plotting the instantaneous velocity of the object across time.
What activity are you on there, Peter?
That's called Freefall 5.
Okay. A while back, there was someone said they needed something about acids and bases.
Oh yeah, we have some really nice acid and base ones. So I think the fastest way is AP Chemistry has a category for acids and bases. So we have from ocean acidification, which is just a really nice real world example of how carbon dioxide in the atmosphere then dissolves into the water, and how that causes the water to become more acidic. So this is sort of an application once students know about acids and bases, but it's a really great sort of real world example. So students look at that over time lapse. They watch this source of carbon dioxide, this candle burns, and then they can see the pH change and the carbon dioxide gas level change, and they can see the color change. So they can really see that that's changing the pH of the water. And then in the part 2 of this, we show them the same situation, but this time we put an actual piece of coral in the water, and let them see that if you have the coral in the water, even though the carbon dioxide level goes up, the pH of the water changes only a little bit and then actually reverts. So you're like, oh, great. Having coral in the water means that the ocean is not acidified. But then they find the mass of the coral before this and the mass of the coral after, and they find that the water was buffered by the dissolved coral. So they see that in the reduction in mass of the coral. But there's some really more traditional ones as well. There's titrations. There's ones where students can get to try lots of different kinds of solutions and look for patterns so that they can kind of discover what does it mean if something is an acid or a base. So it's really worth exploring these. There's some very simple titrations and some more complicated ones.
I know that we polled people earlier and there was mostly physics and chemistry, but would you mind giving a shout out to some of the biology videos?
Well, I would love to. personally, I'm the most excited about the biology ones because that's what we've been working on a lot right now. So I think that for physics, high-speed videography is like this window into things that you would normally not be able to see, collisions and projectile motion and things like that. And time-lapse is sort of the equivalent for biology. So here's our opportunity for students to go through, to learn about Mendelian genetics by collecting their own data. So we have just an example of some seeds. And these seeds, this is just a seed disc that grows over 24 hours, 72 hours, and you can observe that. And then you can look at another kind of seed and make observations that these seeds look in some ways similar and in some ways different. And then we ask the students, well, what do you think would happen if you took those seeds and grew them all the way? And then, so we'll watch here. Here's the question we have. If we call one of those seeds P1 and one of them P2, we then let them watch these two seeds get planted, the same seeds that you saw up above, and then grow through their whole life. So these are the Wisconsin fast plants. So it only takes 40 days for them to go through their entire life cycle, but here it only takes 1 minute. So now we're cross-pollinating those and we're letting them grow. The seed pods grow.
Oh, wow.
And so then we harvest the seeds. So now we know that this is the cross-pollination between those two different kinds of plants. And so the question for the students is, if we plant those, what will we see? And so it's the same idea where the students are going to make a prediction. So it's going to be asked, will they, so the difference is that some of them have red stems and some green. So when you mix these, what will you find? So they make their prediction and then they get to see. Here's exactly what happens. And when we take those seeds from the first part and plant them. So so this is just an example of how, and then I didn't know that much about this. Like my prediction was wrong twice in a row. That you'd think if you grow ones that are half red and half green, you probably think, well, you're going to get half red and half green, but instead what happens is you get all red. Then we allow students to do the same thing. So now we're going to take these all red ones, grow those to maturity, pollinate them, and see what you get. So now if you take these ones that are all red and plant them again, so here's the time lapse showing those ones grow, and then we ask the students to make another prediction, and in many cases they're wrong again. So it's like, okay, well then, right? So this is a jumping off point for them. Then you have students' attention, like, twice in a row, I made a wrong prediction. What is it that I don't understand about how these plants are working? That if I did, I could make accurate predictions.
Can you remind us the name of this lab, Peter?
This one is called, I think, Introduction to Plant Genetics.
Sweet.
And if you're a biology teacher, if you know biology teachers, there are only 16 there right now, but we have in my computer over next to me another 6 or so, and that's our area of most rapid development. There are lots and lots of places where we think that things that would normally just be impossible, like this, impossible to do in a biology class, we can have them do in a relatively short time. And I shouldn't say impossible. A dedicated teacher could have students go through this process, but it would take, months.
Months, yeah. To switch the subject again, there's a question about younger students. Have you any experience with using videos in middle school grades or younger?
So I can jump in there.
Yeah, thanks, Matt.
We haven't really explored those waters too much, but because what we show is the bare phenomenon, like the whole video isn't about a lecture. So we're not like gearing it toward any particular age level. I use it at the college level, Peter's at the high school level. And so Probably a lot of these, many of these would be appropriate at the middle school level as well. They might need some modification, but all of our activities are teacher modifiable. So whereas maybe the current approach is a little more quantitative, I would assume at the middle school level, you might want to be more qualitative and just kind of look at the quality of what's happening or introduce students to the phenomenon. That said, there are some data privacy issues with going younger than 13 years old. So I think that's where we would kind of put the limit.
Yeah. So since it's 4, I just want to acknowledge that that's our hour, and we don't mind staying on if people are interested. Actually, I don't know, Fernand, if we need to call it quits now or not, but I just want to at least acknowledge that thanks for coming and thanks for staying. And I hope that this was useful to you. And even more, I hope that what we are doing is going to help you and your students through this crisis, and hopefully after that as well.
Yeah, and Peter, you probably didn't get a chance to look, but the chat room was buzzing, so.
Great. Nope, I didn't see that. Fernand, how are we doing on time? If people have questions, we want to keep going, or do we want to call it quits? It's up to you. Are you muted?
He is.
Okay.
Yeah, you need me?
We're just asking if it's okay to keep going for a little bit or not.
It's okay with me. And you got 24 people listening. Hey, go for it. I mean, if people don't want to stay, they can leave.
That's right.
Get
We won't
down
say anything
to,
interesting.
some number, or you guys get hoarse or tired, we can stop.
If we're going to go on for a little bit, there's a question that was asked about 10 minutes ago about unlocking sections so students can revise. And the questioner is asking, after grading and commenting, if he edits the lab and unchecks the box to require the section to be completed, does that unlock everyone's lab so they can revise it?
Yes, it does. As long as the students, just refresh the page or reload it, then then unchecking that box at the activity level will unlock it for everyone. You also have the option of going in and looking at a specific student's responses and unlocking that section for that student. So sometimes what will happen is a student type something and then hit that lock button before they meant to. And so then you don't have to unlock it for the whole class. You can just go in and unlock it for that student. So you have either choice on the per student level or for the whole class.
Okay, thank you.
The question about younger students, though, this is another biology one where this is a perfect example of, I think, what Matt was talking about. That here we just have lots of examples of organisms, and in this case, it's fish and a CO2 sensor and an O2 sensor, and we just are asking students to make observations. So we like to think of this as like the first day you're going to talk about cellular respiration, rather than saying anything about what cellular respiration is. Give students this activity and say, what happens? What do you notice? What's increasing? What's decreasing? And then group students into groups where they can look at different organisms. So one group is looking at mice, one group is looking at crickets or a turtle. Watching turtles in fast motion seems inherently hilarious. So you can just, again, students are collecting their own observations and their own data, saying and discussing and saying that there's something that humans and fish and moldy peaches and crickets all have in common. And what a great introduction to the idea of cellular respiration. Did you see the escaped cricket? Did you notice that one jumped out and ran away?
No.
No, I missed that.
That's great.
Yeah, and let me just jump in and say, I think so many of our videos, whether it's momentum or like these biology things, respiration, if the teacher just introduces the concept it can seem quite abstract to the students, but like watching a video, it's just so concrete. And I think the students really feel it's more accessible. So even if they're younger, even if it may be a little too difficult for the teacher to just come out of the blue and talk about respiration, they can obviously see what's happening to the carbon dioxide and the gas and the oxygen in the vial when you put the crickets in.
Yeah, I mean, this is an example of concept and phenomena first,
Exactly.
not words. I mean, science is about phenomena, it's about the real world, and then we
Right.
use words to describe it. But, you know, we have, I don't know how many hundreds of languages with different words, but there's one phenomena, you know, that's some of the universality of science.
Yeah, that's great. That's very well said.
Yeah, very well said. It's the difference between having a course where the activity is completing worksheets versus one where you're studying phenomena.
And we should point out that, you know, if you're a teacher lucky enough to be able to afford equipment like the equipment from Vernier, you could easily do some of these things on your own. You can go to the pet store and get some crickets. The nice advantage here is that we can do so many, so that being able to see this phenomena very quickly across a very wide range of seemingly different organisms and seeing this pattern, that's something that we can do, you know, you can do effortlessly with Pivot Interactives, but would be very challenging to do in a classroom.
There's a question about what this activity is called.
This one?
Yeah.
It's called Introduction to Cellular Respiration.
Yeah. And then
Joseph had a question about the search tools within the community library. And we've talked a lot about somehow ranking those by likes or maybe how useful they are, like how many teachers adopt them. And we just haven't gotten around to doing that yet. But that's definitely on our development list.
Yeah, right. Popularity ranking. We're always, and so the search tools in the community library aren't great. It's true.
A few minutes ago, someone asked if we would just offer some thoughts about introducing this to kids virtually. No, you're not with them right now?
Boy, I almost would be curious to know. That's a great question, and I don't know the answer, because for my students, since we've used it so much, I didn't have to introduce it virtually. I wonder if there is anybody who has done that, whose students' first introduction was after class was after they were no longer had their students in class.
And I realize that you're all muted, so if you want to say something, just put a note in the chat window. I would just say that, like Peter, my students are used to using these, so I think it'll be no difficulty transitioning to online. But what I would do is I would just make a highly scaffolded activity where I give them like whatever activity I wanted to do for that particular unit. I would just make it very highly scaffolded. So I'd have them watch the video and then answer, like, did they successfully watch the video? Did they find the tools? Did they open the tools? Could they use the tools? And with auto-graded multiple choice, I would put a check, like a multiple choice question following each of those tasks that they need to complete. And then after they complete the task, they can get immediate feedback about whether it's right or not. And then that way they can step all the way through. And I think after one highly scaffolded thing like that, they would catch on pretty quickly.
I like that idea. I know that Screencast-O-Matic is opening up their service. So what a teacher might do is, a Screencast-O-Matic will record everything on your screen and make a video from it. So you could show the students how you manipulate the tools and navigate the site and enter stuff. That's possible too. I think the questions have stopped.
Okay, cool.
I would bet that the kids nowadays, you know, they're pretty inquisitive and pretty, you know, click oriented. So, you know, I mean, this has a lot of different options, and they might get kind of lost, is true. But you know, the idea of phenomena first, you know, pick some really direct, simple sort of thing that they could watch and, you know, maybe explore or to run it several times and discuss what the options are. I think there, you know, look, I think all the good ideas for how to do these things virtually are still to be discovered. So let's go out there and figure out how to do it. And, you know, this gives us a great foundation of real phenomena to do it from. And, you know, kids, maybe some kids will be able to go into their basement and try it all.
Yeah, wouldn't that be great?
Yeah, I think that'd be great. That would be fantastic.
Yeah, upload their own stuff too.
Right.
Sure.
Right. I mean, that would be, you know, I keep talking about the fact that virtual and being at home offers certain things. My PhD was labs you could take home, and what was the advantage of doing that? And there are a lot of advantages. One is kids spend 6 times as much time if you let them take the experiment home than if you have to make them do it in the lab. And I think that would be true here. If they find something they really like, they could work on it. Anyway, this has been a fantastic session. Peter, great job. Matt, great job. Wonderful team with Craig and, you know, helping each other out. So thank you. And I think that it's coming now time to say goodbye and to thank you guys again. And good luck with Pivot Interactives. And we'll see where that goes. And hopefully the virus will go away, but Pivot will be here.
Yeah. That's right. Thanks, Fernand, so much for enabling this. We really appreciate the STEM Teachers NYC hosting this and hopefully allowing us to share this with teachers in a way that will help them. So, and I know that you all do an awful lot of other beneficial things for teachers. So thanks for that as well.
Yeah, we'll be back next Friday. I mean, Tuesday, Thursday, and Friday. Yelena is doing a fantastic job providing support at 4 o'clock. 4 o'clock, and also sometimes Monday and Wednesday. So we'll be around and hopefully help everyone get through the crisis. Okay.
Well, thanks to her, and thanks to you, and thanks to Matt and Peter.
Yeah.
Thanks so much.
Peter,
Take care.
yeah,
All right.
you can
Take care,
close
everybody.
Yeah. Bye-bye. You can close the session, Peter.
Okay. I will. Bye-bye.
Right. Bye.